Right, this one's really pretty, right? It's a cube with a plane shooting diagonally through the cube, creating a triangular cross-section. So it just wants to know what kind of triangle is created. So when the plane cuts through the cube, this is called a cross-section. Remember, a cross-section is a two-dimensional figure. It's usually a polygon, but not always. Two-dimensional figure formed when a plane intersects a 3D solid. So all we have to do is use they already gave us a variable. They said use S, and we can find the side links. The side links will tell us what kind of triangle has been formed. So this triangle right here, what type of triangle is that? It's right. This plane is going through the vertices. So when you connect vertice to vertice, yeah, you get a 45, 45, 90 triangle. So 45, 45, 90 goes S, S, S root 2. So we found a side. Now, what about this one? Well, that's connecting a vertice to a vertice. And no matter what, all the sides of a cube are squares. If these are all squares and we keep connecting vertice to vertice, then we're going to get S root 2. And then for this one, vertice to vertice of a square is going to be S root 2. So even though those are isosceles triangles, the cross section is an equilateral triangle because all of the sides are S root 2. They're all congruent. The answer is equilateral. 13. Okay, so we've got a trapezoidal prism. They gave us multiple choice. We don't have a computer software, although you could log back in to that other one, but I don't think you could have made the base a trapezoid, even if you tried. So what we need to do is try to visualize. I'll overlap them a little bit. Try to visualize a trapezoidal prism and try to visualize slicing this different ways. So we know in a prism, you learned on your discovery that if you take the cross section parallel to the base of a prism, if you're parallel to the base, you're going to get the shape of the base. So we know that if we cut through it like this with our plane, we are going to get a trapezoid. So that's not the right answer. Let's cross it out actually. We know if we're parallel to the base, we get whatever the base is. Okay, so now we don't want to be parallel to the base. Let's see what we would get if we went perpendicular to the base. So if we cut it like this, or through that way, if you can tell. Well, actually, we're going to get whatever you see on the top. What do you see on the top? We're going to get a rectangle. And you better believe, guys, anytime you can get a rectangle, you can get a square. It just means that the depth of the height of the prism is the same as like one of the bases. So normally when you can get rectangle, you can get square because you can force those two lengths to be equal. And then, you know what? Even if you can't visualize whether you can get a triangle out of it or not, it's our only one left. So sometimes process of elimination works. All right, 15. A plane intersects a cylinder. Plane intersects a cylinder. Which of the following cannot be formed by the intersection? So we know when a plane intersects a cylinder parallel to its base, we get a circle. We know that when a plane intersects a cylinder perpendicular to its base, we get a rectangle or square. Here's what we didn't do yesterday. We didn't talk about it. Remind me what it means when a line intersects a circle once and only once. What's that called? Ooh, Toby was first. We're going to use the concept of tangency to explain these last two. A plane could intersect a cylinder and be tangent to the cylinder, meaning it's touching it in a segment or a line. It's just barely grazing the cylinder. I'm not slicing it, I'm intersecting it in a line. I'm tangent to the cylinder. Did you know a plane can also intersect a cylinder in a point? It's when it's tangent to the base. Look, a plane can be tangent to a circle and intersect it only in one point, right there. So point is another one that could be formed. What cannot be formed, because there's too many curves, you can't form a triangle. You can't get 3 straight sides. You can get like a spherical triangle that's kind of curved, but you cannot get a true triangle out of that intersection. If you don't want to make any assumptions here, yes, so the first one would be rectangle. The next one would be rectangle. Technically, this one would be rectangle, because who said that that was a square? Unless you're assuming that it's a regular pyramid. Most of our pyramids are regular. So there would be literally 4 rectangles in a row. You wanted to say that it's an isosceles triangle. Yeah, as long as that was perpendicular, well, either way, yeah, slant height equals slant height, right? So if you want to embellish that and write isosceles triangle, that would work for me. The only time it wouldn't be isosceles is if the cone, well, you know what, it might be isosceles in this case too. If it were like an oblique cone, oblique means the apex of the cone is not directly above the center of the circle. But yeah, isosceles triangle is a good description.